Welcome to the walkthrough of Part A in Assignment 2 in my CS 5254 course in the summer of 2023. The objective of the first part of this two-part assignment is to learn how to use the Java Executor Service framework, as well as to recognize its benefits relative to using Java thread objects directly. Videos describing the Java Executor Service framework appear here and here. I recommend you watch these videos to ensure you understand the structure and functionality of the Java Executor Service. Naturally, we'll cover these topics in class as well. In this part of the assignment, you'll use an implementation of the Java Executor Service interface that's created with a fixed size pool of threads to enhance the multi-threaded implementation of the Palantiri simulator app from Assignment 1A. Your Assignment 2A solution uses this pool of threads to allow beings from Middle-earth to concurrently gaze into a fixed number of palantiri. By now, you should understand what palantiri are. The Palantiri Simulator app is packaged as a project using the latest version of Android Studio. This app is written in both Kotlin and Java and demonstrates many Android capabilities. For the purposes of Assignment 2A, however, you only need to be aware of the following three directories. The Simulator Manager's Beings Executor Service directory, which contains the skeletons you need to fill in, as we'll talk about shortly. App Source Test, which is a set of unit tests that exercise many Palantiri Simulator features and can be used to help test the functionality you implement for this assignment. And App Source Android Test, which is an Android Studio instrumentation test that runs your app automatically. To compile this code, you need to use the provided Android Studio project. You can run this project by clicking the green Run App button in the Android Studio IDE, which should automatically select an Android emulator to run, assuming you have one created. The app is designed to work with Android API level 33, so you'll need to select an emulator that uses API level 33. If you don't already have an emulator created, you can create one by clicking on the AVD Manager button in the Android Studio IDE. You'll need to modify several files containing the skeleton Java code by completing the to-do, you fill in here tasks to provide a working solution. Don't change the overall structure of the skeleton. Just fill in the to-do tasks and do not delete the to-do tags. In particular, you need to finish implementing the following to-do tasks for this assignment in the Executor Service folder. You'll first need to implement the Executor Service Manager.java file, where you'll need to complete the to-do tasks in various methods to implement a being manager via a fixed-size thread pool using the Java Executor Service class. You'll next need to complete a couple of methods in the being callable.java class. And finally, you'll need to complete the student.kt file to set the type field to either graduate or undergraduate, depending on which version of the assignment that you're implementing. In addition, you'll need to integrate your solution for the spinlock hashmap folder from Assignment 1B into the latest greatest spinlock hashmap skeleton and use it as the implementation of the Palantiri Manager for Assignment 2A. Just as a quick note, Assignment 2B, which will be coming out soon, will extend the Palantiri Manager's superclass to use a new and different group of Java synchronizers. Your app will be considered correct if it passes all the unit tests and instrumentation tests and all the beings successfully complete all their n iterations. A correct simulation should restrict the number of gazing beings to the number of palantiri. In other words, if there are 4 palantiri in the simulation, then only 4 beings should ever be gazing on the screen at a time. When the simulation is running, the app view will display visual feedback to show palantiri and being states, as well as the progress of their gazing iterations. If your assignment implementation is correct, and it doesn't throw any exceptions, then the app title bar labels will appear green when the simulation completes. However, if your solution is not implemented correctly or throws an exception, then red title bar labels will be displayed when the simulation completes. Graduate students, or students who are taking this course for graduate credit, must perform the following additional tasks. Enhance the Executor Service Manager.java file to use the Java functional programming features like method references and/or Lambda expressions. Likewise, if you're familiar with the Java Streams framework, please feel free to apply it to your solution. Undergrads are welcome to implement these features and methods, but it's not required. Skeleton code for this assignment is available in my GitHub account in the normal location. Now that you've set up a GitLab account, you can pull my skeleton code into your repository, read it carefully, and complete the to-do markers. The additional work required by graduate students is clearly indicated. There are unit tests in the App Source Test folder. We provide these to increase our confidence your implementation is working as expected. It's essential that you use the Android Studio GUI to run these unit tests locally on your computer, as described here and shown later in this video. As usual, testing only demonstrates the presence of bugs, not their absence, so don't rely solely on the test to detect problems in your code. In particular, I'll also provide videos that walk through frequently made mistakes that you should address. Please make sure you address these issues prior to your submissions to streamline our programming assignment review and assessment process. This assignment is designed to deepen your knowledge of writing concurrent Java programs using the thread pool features provided by the Java Executor Service framework, which enhances the core Java multi-threading mechanisms we focused on in Assignment 1A. This new assignment doesn't require you to program any other Java or Android concurrency frameworks or synchronizers for that matter, which we'll be covering in later assignments. Now that we've walked through the specifications, let's take a look at the skeletons you'll need to implement to complete Assignment 2A. So what you'll do is come into the app source main folder and then look in simulator. And you can see simulator has a number of subfolders. Where you're going to focus is managers. There's two parts to this. There's beings and there's palantiri. Palantiri contains the spinlock hash map manager you should have copied from assignment 1B. Likewise, the beings folder has the runnable threads subfolder that you should have copied from assignment 1A. And then you will fill in the implementations in the executor service subfolder, including being callable and executor service manager. So let's take a look quickly at being callable. This is the class that implements the gazing logic for a being in this program. And you can see here it extends the being class and it implements the callable interface. By implementing the callable interface, that means it has a call hook method that needs to be overridden. And in order to do this, you have to replace null with the statement that will return the appropriate being callable. Hint, this is really simple. Down here is the acquire palantir and gaze method, which is going to get a palantir from the being manager by calling the appropriate superclass or base class helper method. This call will block if there are no available palantiri. And if a concurrency error occurs in this implementation, null is returned, and that should immediately cause you to call being error, which will throw the illegal state exception. You can see that code by poking around through the subclasses here and the superclasses. Then what you'll do after you get the appropriate palantir is you'll gaze at the palantir for this being, which will block for a random period of time. And then finally, you'll release the palantir for this being via a call to the appropriate base class helper method. Please make sure you structure this code correctly so that if exceptions occur, you'll release the palantir even if something goes wrong. Having said that, also please make sure you structure this code correctly so that you're careful not to do the acquisition of the palantir in the try block, because if that happens, then the finally block may try to release an incorrectly initialized palantir. So there's a little tricky code here that you'll need to get right. Let's now go ahead and turn our attention to Executor Service Manager. This is a being manager that uses the Java Executor Service, which will create a fixed size pool of Java threads that run the being simulations. So you'll need to create a list of futures to being callables that will be run concurrently by the Executor Service's thread pool, so you got to fill that in. You'll also need to have an Executor Service instance that will contain a fixed pool of threads. You need to fill that in. And then down here, you have to implement the new being factor method, which creates the appropriate being callable. That's pretty simple, but you have to be a little cognizant of the parameter that's passed into the being callable constructor. So think about that carefully. The main entry point here that kind of starts off the simulation is called run simulation. The first thing you're going to do is you're going to call a method defined below that will use the executor service to create and start a pool of threads that represent the beings that are being simulated in this program. Then you'll call a method that waits for all the futures to complete. And then finally, you'll call the shutdown now method in this class to cleanly shut down the executor service. So let's go ahead and take a look at each of these methods. I think you can figure out which ones to call when. So create executor service will create a fixed size thread pool executor service, and make sure you do this correctly so that you have the number of threads in the thread pool that's allocated properly, and that will return a fixed size thread pool executor. Once you've got that created, then here's the begin being thread pool method. And this has got a few interesting things going on here. You'll first call the create executor service factor method to create an executor service instance that contains the fixed size pool of threads. You should use the get thread count helper method to set the number of threads in this pool. This helper method will retrieve the thread count from the application settings panel, which you could actually set when you start the application running. And that allows you to dynamically tune the pool size at runtime. You can also see how the size of the pool affects the level of concurrency. You can see that when you run the GUI. And then you'll go ahead and call the being manager getBeings method, which will be used to iterate through the being callables and submit each being callable to the executor service, and then add what comes back from that, from submit, to the list of being callable futures. Now, the grad students have to do some extra stuff here. They have to use Java Streams. Undergrads are free to use Java Streams if they want to, but it's not required. And when grad students do this, they should use Java Streams to submit each being callable and then collect the results into a list of being callable futures. Using Java Streams removes a whole bunch of accidental complexities associated with using lists and array lists in traditional Java or old school Java. Then you'll go ahead and call a method to create the executor service instance that contains the fixed size pool of threads, and use a superclass helper method to get the thread count that was described earlier. Down here, this is the code that the undergrads do. This is where that goes. This is the code that the grad students do, and you'll put those in the right place. And then finally, here's one of the second to last methods. This is called await completion of futures. For the undergrad students, you'll use a for loop to wait for all the futures to complete. When all the futures have completed successfully, you'll set a flag that will be used to log the success or failure of this method. Note that if a checked exception is thrown, catch that exception, immediately stop processing, and then wrap and rethrow the exception as a runtime exception. Checked exceptions are kind of a pain in traditional Java, which is why we wrap them often. Graduate students should use the Java for each method instead of the Java for loop to process the futures, and also use the exception utils rethrow supplier method to avoid the need for this very frustrating and verbose try-catch block to handle checked exceptions. Make sure that your solution doesn't contain any try-catch blocks if you're doing the grad student version. And when all the futures have completed successfully, set a flag that will be used to log the success or failure of this method. Undergrads can use this approach, but you don't have to. So down here, once again, please make sure you put your code in the right part of this if-else statement. And this then kind of prints things out when you're all done to show what worked and what didn't. And then at long last, we get to the shutdown now method, which is called above by the run simulation entry point to terminate the executor service. This method should only return after all threads have been terminated and all resources have been cleaned up. So the first thing you'll do is you'll go ahead and cancel all the outstanding being callables by their futures, by canceling the futures if they're not done, but only cancel futures if they're not already done or if they're not already canceled. And then once you've canceled things, then you go ahead and shut the executor down now. So the key focus there is now. You want to shut it down at this point. You don't want it to wait. You want to tell it to stop immediately. So that's essentially what you'll need to implement here. There's also something else you need to fill in over under the utils folder, where you have to fill in whether you're a grad student or an undergrad student. But I assume you know how to do that. That's pretty straightforward. So that's the end of the walkthrough of the skeletons. Now that we've walked through the specification and the skeletons, let's show how to run the tests, starting with the unit tests. To run the unit test, you come down here to test, and you right-click on this or whatever's required in your IDE to run the tests, and you click on Run Tests, and that will go ahead and instantiate the tests. And it takes a little bit of time to instantiate the tests, so we'll just let it run for a second, and then I'll take a look and see what happens when it starts to run. So you can see the tests are beginning to run now. There's two different types of tests. There are white box tests, which look at the code that you've written and give you feedback, very specific feedback about how to implement the functions properly and the functionality and the methods properly. And then there's also black box tests, which are really trying to stress out the system to make sure everything works correctly in a multi-threaded environment. As you can see, we have a lot of tests. There are 62 tests. All of your tests should pass. If for some reason some of your tests are not passing, then make sure you come and ask for help, and we'll see what we can do to get things to work. The final thing we're going to do here is run the instrumentation tests. To do this, go into the app source folder and right-click on Android tests and click on Run All Tests or whatever is required on your system to get these tests to run. You can see it's going to go ahead and start compiling the instrumentation tests, and then it will launch the emulator. And when we see that that happens, what we want to do is come over here and we'll shut down the Run tab. And over here you can see that the Pixel 6 emulators coming up. You don't have to use a Pixel 6. That's just the one that I happen to use. And as soon as that is launched, then the tests will begin to run. As you can see here, these tests have 10 beans, 6 palantiri, and 10 iterations each. And during the running of the tests, it rotates the screen to make sure things continue to work correctly even when screen rotation takes place. And if all goes well, when we're done, we should have 100 iterations completed successfully. You can see here that that worked fine. We had 10 threads. Those are all things that are expected. Now, these instrumentation tests will continue to run a couple other passes. They run at a super duper speed in order to put your code to the paces. And the reason we do this is that when you're running and testing concurrent programs, it's sometimes hard to figure out what's going wrong when you just run them once. So we actually run them multiple times, because the more we run them, the more likely that any race conditions or other hazards of concurrency will manifest and rear their ugly heads. So I'm not going to keep running these here, but you should do that for your code to make sure that everything is working correctly.